Today we're looking at identifying arithmetic sequences. We're going to hopefully be able to identify sequences that are arithmetic sequences and use the common difference to determine the specified term of an arithmetic sequence. For example, being able to say, like, what's the 20th term in this sequence going to be? Well, hopefully by finding the common difference, we can extrapolate what it is. So let's look at number one. Look at these toothpicks that make these models. We want to go ahead and draw the next two. And then you'll notice that it is 1, 2, 3, 4, 5, 6, 7, 8 toothpicks. And then the next one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we can already kind of see what the pattern is, but let's go ahead and draw. I'm going to draw over the side since I don't have that much room. And it's going to be a little bit messy, but just doing the best you can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Then we'll look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Oh, I forgot the one right here, 26. I was wondering, how did I get 25? It's supposed to be going up by 6, but right here was one. I didn't separate this bottom one into 2. It's always 2 on the bottom. Okay, so 26. And then you can kind of guess what the next one's going to have. It's going to have 6 more, 8 and 6, 14 and 6, 20 and 6, 26 and 6. It'll be 32. Let's see. This is going to take a minute. What did it have? That had 4 boxes, so this next one's going to have 5. So that's 3. Oop. This shouldn't be there. This is 5, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 32. Now let's complete the table. 1, 8, 2, 14. 3, 20, 4, 26, 532. Use the following grid. Let's make this, what was it, 1, 8. So about here, 2, 12 here, 3, 20. No, I'm sorry, 18. No. I'm already farted. Hold on, let me start over. I have such a bad memory, which is why it's good to look back at your answers. 1, 8, 2, 14, 3, 20, 4, 26, 5, 32, and then 6. Oh, we didn't go to 6, but that's how that would be. Is your graph discrete or continuous? It's discrete. Okay. Why? Explain your answers. Individual stages. Okay. Have certain numbers. We don't have anything in between. I don't have 1.5, stage 1.5, or stage 2 in the third, or 2.4. It's only the whole numbers are our stages. Is the graph a linear function? It looks like it, yes. An ordered list of numbers is called a sequence. This is like one of the very first lessons we did in this book. The numbers in a sequence are called the terms. Don't forget these. This was what we learned in the very first lessons. To refer to the nth term, okay, that just means whichever term we care to talk about. It could be the first one, the second one, the third one, the 8th one, the 100th one. You can use either function notation, f of n, or the indexed variable a to the n. Okay, now this is a subscript, not a superscript. It's just saying which term are you talking about. It could be the 5th one, a to the 5th, with a sub n. Okay, subscript, not superscript. The toothpick data form a sequence. The number of toothpicks at each stage are the terms of the sequence. Okay. What are the first 4 terms? Remember, the number of the toothpicks is the term. So the first one had 8, and the second one had 14, the next one had 20, and the 4th stage had 26. In a sequence, what is the distinction between a term and a term number? Okay, the term number tells you which stage you're looking at, while the term is basically like the answer, how many it is. Okay, so the term, let's think about it a different way. The term is the answer, like 26. The term number is which one you're talking about. This is the term number 4. It's the 4th stage, okay, the 4th part. And the term that we're talking about is what is the 4th part? 26. So it's a very subtle distinction. You got to kind of think about it. Let's look at number 7. For this sequence, 7, -5, -3, 1, 1, what is A4? What is the 4th term? This is the term number. What is the answer? So 4th term is 1. A4, A sub 4, the 4th one is 1. For this sequence, what is the 5th one? The 5th one, 1, 2, 3, 4, 5 is 17. A sub 5 is 17. The 5th term number. Common difference can be called common constant difference. Oh, more words that mean the same thing. An arithmetic sequence is a sequence in which the difference between the terms is constant. Okay, so this was an arithmetic sequence because each one had a difference of 6. The common difference. And that is what the difference between is called, the common difference, how much it changes. Why I just told you, because it increases by 6 every time. Increases by 6. What is the rate of change? 6. Okay, for the toothpick data, it changes by 6. Look at the graph in number 4. What's the slope between any 2 points? All right, it went from 8 to 14 over 1. The slope is also, remember, common difference 6. Describe the connection between slope, rate of change, and common difference. They're the same thing. Okay, slope, rate of change, common difference, constant of variance, same thing. Just like when we had x is the input, the independent variable, the domain, y was the range, the output, the dependent variable. A lot of these things are just the same concept written in different ways, but for whenever you're talking about certain parts of the problem, whatever the context of the problem is, you use a different word to say it, but it's basically the same thing. All right, let's see if each one of these is arithmetic, and if it is, find the common difference. All right, 9 to 6, that's 7. 16 to 23, 7. 23 to 37, 37. Yes, so this is, yes, it is an arithmetic difference, and the common difference is 7. Negative 24 to negative 20, plus 4. Negative 20 to negative 14, that's plus 6. Or I can already tell, plus 4, plus 6, plus, so no. Not a arithmetic sequence, it's changing. 2.8 to 2.2, that's 0.6. 2.2 to 1.6, 0.6 to 0.6, yes. 0.6. 3, 5, that's 2 to 5 to 8 is 3. 8 to 12, it's 4, something. No, it's not a common difference. And then 1/4 to 1/2 to 3/4. You're adding 1/4 every time, so that is actually a common difference. Don't let the 1/2 fool you. That's really 2/4. 1/4, 2/4, 3/4, 1. It's adding 1/4. Can the common difference be negative? Yeah, that's fine. It would just be a decreasing sequence then, instead of increasing, but it'd be negative, it's fine. All right, so arithmetic sequences. If the common difference, the slope, constant of variance, the rate of change, if the common difference is the same every time, it's an arithmetic sequence. If it's not the same every time, the common difference, it is not an arithmetic sequence. That's basically what this is. Reading about sequences and seeing if there's a common difference. Go ahead and try 18 through 24 to see if you got it. But remember, it's not that hard of a lesson if you just put it in those terms. Does it have a common difference between each term in the sequence? Yes, arithmetic sequence. No, not an arithmetic sequence.